In the second notes for section 2.5 on implicit differentiation, I'm going to give you the specific steps and then go through two examples. I'll also put a couple of the homework ones. I'll post those also. I'll maybe do those in a day or two so you have something to look at to see if you're doing them right. So again, in the first set of notes we discussed about how implicit differentiation is used when the x and the y are on the same side of the equation. It's often used when you can't easily, if at all, solve an equation for y. That does not mean, and oftentimes it's not even a function, but that doesn't mean derivatives don't exist. This thing right here is not a function, but I do have a tangent line right here, and it does have a slope. So technically I should be able to find the derivative. And what we do is a process called implicit differentiation. And I'm going to give you the steps and then I'll take you through a couple examples. So the first thing you do for implicit differentiation is that you take the derivative of both sides. And we're going to keep that one in formal notation. So take the derivative of both sides. And the way we're going to write that, I might as well start that down here, is we're going to say that the derivative of the left-hand side with respect to x has got to be equal to the derivative of the right-hand side with respect to x. So I'm taking the derivative of the left, setting it equal to the derivative on the right. Once I've done that, I'm going to apply all derivative rules that are necessary, derivative rules, and actually any pre-algebra, algebra rules, and that kind of stuff. Now, keep in mind that when you take the derivative of, say, 4x squared, you don't need to write this, with respect to x, we just say, well, that's 8x. We use the power rule. But had this been some other function, for example, we sometimes call it u, and we say, well, what's the derivative of that with respect to x? And we say, well, u is itself a function. So we say it's 8u times du dx, or u prime. That concept holds a lot here or is used a lot here in implicit differentiation because you're going to be taking the derivative of some quantities y, not x. So if there's not a variable match here, you've got to consider it a chain rule function. And so when I say all derivative rules apply, that means power rule, product rule, quotient rule, ton of chain rule, all that kind of stuff. So down on the bottom here, if I were to go do step 2 on this one, I'd apply all my derivative rules. I'd take the derivative of y cubed with respect to x, which would be 3y squared times the derivative of y, or again, I'm chain ruling it. So we're going to go to the more easy notation, which is to just use y prime. Then if I'm doing sums and differences, I just do them separately and add them up. So then I would take the derivative of y squared, which would be 2y, y prime. Then I take the derivative of minus 5y, which again the constant multiple rule says this does not affect it, and you take the derivative of what's left. Well, the derivative of y is itself y prime. And the derivative of x squared with respect to x is 2x. And on the right-hand side, as always, the derivative of a constant is equal to 0. So I applied my derivative rules that I could for that one. Keep in mind that every time I did my derivative of a different variable, I had to consider it the chain rule and take the derivative of the guts once I had done the problem. All right, so next I would say our goal is to isolate y prime. Again, we're trying to find the derivative or the slope of the tangent line at any point along that graph. And so what I'd like to do is isolate y prime, which means I'm going to move all y prime terms, or terms containing y prime, to one side. Usually we do that on the left-hand side. And then what I will do is I'll solve for y prime. And usually that involves some factoring, and usually that involves some division. All right? So let me go do steps 3 and 4 down here on this bottom problem. So I've already done step 1 and step 2, and now my goal is to isolate y prime. So I'm going to take all my y prime terms, these, and I'm going to keep them over here on the left. So I've got 3y squared times the derivative of y plus 2y times the derivative of y minus 5 times the derivative of y. I'm going to move this one and get it out of the way. And my goal is, again, to solve for y prime. So now I'm going to pull it out of every term. I'm going to factor it. So I get y prime times 3y squared plus 2y minus 5 is equal to twice x. And again, if I want to isolate this and I'm multiplying it by this quantity right here, to solve it for y prime, I'd simply divide both sides by 3y squared plus 2y minus 5. And again, I have an equation implicitly in terms of x and y for the derivative. It's not like we've been getting where we've been saying, well, dy dx is, say, 4x minus 2. It's just explicitly given in terms of x. Now it's implicitly given in terms of both x and y. So where it says where's the slope of the tangent line undefined, well, that would be where this equation or the derivative is undefined, which means the denominator can't be equal to 0. So we had said 3y squared plus 2y minus 5 equal to 0. You would factor and you would solve it. I don't want to go through that just for time purposes. And then it says find the equation of the tangent line to the graph. Well, that's been a pretty standard question for us. We know that in order for us to get an equation for any tangent line, we need a point, which they've given me, and I need the slope of the tangent line, aka I need the derivative. So I would say y minus negative 3 is equal to the slope of the tangent line times x minus 1. And in order for me to get this slope of the tangent line, I would take the x and y value from the point, and I would go plug them in to the other equation, and I would have it. So, moving on to the next page. We're going to do one more here. Alright, so in the next one, I am again in search of the derivative, and then I'll write an equation for the tangent line. So again, I know this would be a candidate for implicit differentiation because it's not in the form y equals, and nor can I easily solve it. I don't even know if I could at all solve that for y. So what I will do is I'll take the derivative of both sides. So I'm going to take the left-hand side and take its derivative with respect to x. Likewise, I'll take the derivative of 8 with respect to x. When I do that, keep in mind, any term that's got a variable match, I just use my differentiation rules. My derivative of x squared is twice x, the power rule. The derivative of 6xy requires the product rule. So I'm going to consider 6x my first function and y my second function, and I'm going to do the product rule. I would suggest every time you do the product rule, you lock it in a set of hard brackets. Because had this been a minus, which would mean subtraction, which would mean right here we'd have a subtraction instead of addition, it would have to get distributed. And if you don't put the brackets around there, I think you're going to forget to do that. So we're going to go apply the product rule to term number 2, which would say the first function times the derivative of the second function. Well, the derivative of y is simply y prime. Then we do plus the second function, which is y, times the derivative of the first function, which would be 6. Then I've got to take the derivative of y cubed. So again, I power rule it and then take the derivative of the guts. And I set that equal to the derivative of 8, which is 0. Now, my goal is to isolate y prime. So I will keep all terms involving y prime on the left-hand side of the equation, while moving all terms not involving y prime over to the right-hand side of the equation. So I'd have a minus, oops, sorry, this was a cubed. This should be a 3x squared. Sorry. How is that going to affect everything? Not much. So this would be minus 3x squared minus 6y when I move that over. Again, I'm taking my non-y prime terms, sending them to the other side. I am now going to factor y prime out of the top, so I get a 6x plus 3y squared. And a lot of algebra going on here. Lastly, in order for me to isolate y prime, I'm going to have to divide both sides by 6x plus 3y squared. So I have y prime is equal to negative 3x squared minus 6y all over 6x plus 3y squared. And I've got an implicit formula for the derivative of the graph. Now, it said to find an equation of the tangent line. So again, I need a point. Well, they gave one to me. So I'd say y minus the y I know is equal to the slope of the tangent line times x minus the x I know. And I would take that point, that 1, 1, and I'd go put it in my derivative function. This time, it's dependent on both the x and the y coordinate, not just the x coordinate. And when you plug that in, you end up with a negative 1. and you can go ahead and leave that there. So what I'd like to do, your homework for this section is on your calendar, so I'll go pop that up here really quickly, and then I'm going to do number 13. Actually, I think what I'll do is I'll just do a couple of them on a separate video. So I'm going to pretty much be done with this. Let me just go point out what your homework is. You have this right here, page 146, 1 through 15 odd, 21 to 25 odd, and number 33. And we're going to make that one due Wednesday. What I'd like you to focus on the most over the MEA weekend is that derivative packet. It has a hot pink cover. You were to do the odds. I think I handed it out way back on this date. Here it is, right there. You were to do the odds, and the evens were extra credit. So focus on the derivative packet. I've posted the solutions to that, so you need to supply the work. Then, once this is complete, wrap this up. That'll be due on the Wednesday you come back. What we're going to do on Tuesday is we are going to take and do some home expert groups with some more difficult implicit problems. So each group will be in charge of 1 or 2 problems, and then you'll branch off and you'll teach those. And you'll see I don't have any homework given on this day here. So, oh, I just splashed up here by accident. So that's the end. Again, sometime this MEA weekend, I will post some of these solutions on here, just so you know if you're doing them right. You guys have a great long weekend.